In this video, we are going to talk about polynomial regression. So let's start with the problem statement. So let's assume that you work for a company and that company hires a new employee and he says that he was a region manager at the previous company and is demanding now 180,000 as his salary. So we are given the task to see whether he was saying the truth or not and how much salary should we really pay him. So we are given this data set. So as you can see, there are different positions from business analyst to the level of CEO, and corresponding to those positions, there are levels assigned to them. For example, business analyst is level 1, which means this is the lowermost position that the company offers, and CEO is the maximum or the highest position that the company can offer. And respectively, their salaries are given, which varies from 45,000 to a million. So our job as a data scientist or as a machine learning engineer is to find out whether that new employee was saying the truth or not. So as you can see over here, the salary of a region manager is around 150,000 and he's demanding around 180,000, which is not very far away because he might also have some experience with him as a region manager, and salary increases with experience. So he might be saying the truth, but let's analyze this data using our regression models and see how things work. Okay, so we first start by importing the libraries. So basically, we are going to use four libraries. These are NumPy. NumPy is basically used for arrays. Matplotlib is used for visualization of our machine learning model, and pandas is basically used to access the dataset as a data frame. We'll also be using scikit-learn library to train our regression model, but that will come later in the code. So now let's just execute this cell. So the next step is to import the dataset. So we'll be using this pd dot read underscore csv function, and from that we'll be importing the position salaries because the name of our dataset is position underscore salaries dot csv. Here we'll be using the level column as the independent variable and salary as the dependent variable. So we'll just import them. So for x, to import this second column, we'll have to use 1 colon minus 1 because the position will start at 1 and finish with minus 1, and this minus 1 of the salary column will not be included in this particular x because this is how this thing is defined. So only we'll get the level column as x, and in y we'll get the last column, which is also represented by minus 1 indexing, and that is a salaries column. To double check, we'll also see what values of x and y are assigned here. Okay, so let's add a new column and see x. Yeah, so as you can see, x is an array, a 2D array basically of the levels that there are, and let's also check y. So yeah, as you can see, this is a one-dimensional array of the salaries of different levels position employees. So what we are going to do now is we'll be comparing the two models that we have studied. One is the linear regression model, and then we will train the polynomial regression model on this data set to see which one is better on this data set. So let's start by training the linear regression model on the whole data set. So here we don't need to worry about the accuracy of anything of that kind of, because we don't have recurring values. For example, we have only one value of level 1 and corresponding that be only one salary. So there is no real way to check if our predicted value is coming close to the actual value or not. If we had one more level 1 value corresponding to some different salary, we would be able to find if our model is predicting accurately or not. But in this case, it's almost impossible to see if our salary model is predicting the correct value or not. The only way to check what we are doing is correct or not is to see the visualization and after using that we need to check if the regression model is doing it correctly or not. Okay, so now we need to train the linear regression model on the whole data set. So we'll use the linear model module from the scikit-learn library, and from that module we will import the linear regression function. We will first initialize this function using these parentheses, and then we will fit the values of x and y into this linear regression model. Okay, so now our model is trained. So now let's train the polynomial regression model on the whole data set. So there is nothing known as a polynomial regression in scikit-learn. So what we'll do is we'll transform the values of x polynomially. For example, we'll make it a degree of 4 or maybe a degree of 2 or 3. We'll try different values of degrees, and we will change the values of x, and then we will apply linear regression because because we have changed the value of x, so it won't be a linear regression, rather than it will be a polynomial regression. So this is how polynomial regression works. Okay, so from first we have to import the polynomial features function from the pre-processing module of the sklearn library, which is represented by this step. So the next thing we have to do is we have to consider a variable called polyrect, and in that we are going to initialize the polynomial features function with a degree of 4. So here you can also change the degree to 2 or even 3, but right now we are going to use a degree of 4. So what we're going to now do is we are going to make a new variable called x underscore poly, and we'll apply this fit transform method of the polyrect function that we made over here, and we are going to transform the values of x. So we are going to transform the value of x by the degree of 4, which means that, for example, if our value of x was 2, it will become 2 to the power 4, which is 16. So this is how things will change. And then we are going to apply a linear regression model, but we know that it is a polynomial regression model because we have changed the values of the independent variable to the power of 4. So now we'll just fit the model. So we need to define a new model. We cannot use lin underscore rect like we used here because this is a different model. So we need to create a new model, lin underscore reg underscore 2, and first we need to initialize this using linear regression, and after that we are going to fit the values of x underscore poly and y underscore poly. So now let's make this model. Okay, we can also check the values of x underscore poly. So as you can see, first the value is 1, then it is 2, 4, 8, 16, and then it is 3, 9, 27, 81. So basically these are the different values that we get when we apply this polynomial regression function on x. And we'll also see how things change when we change the value of degree that we are using over here. Okay, so now we need to visualize the linear regression results to see how our linear regression model did. So basically, so as you can see, this blue line represents our linear regression model, and as you can see, it doesn't do a very good job. It only predicts one value correctly. So we know that this is not the correct way to approach our problem, so we need to find something different, and that's the reason why we use the polynomial regression results in this case. So now let's plot this graph also. The only thing you need to remember here is this: we are using the x value, and in place of y we are using the predicted value. So what we first did here is we transformed the value of x, which was what we did originally over here. So as you can see, we transformed the value of x and used it at x underscore poly. So rather than using x underscore poly, we did that whole step again using x fit underscore transform of x. And then we applied the polynomial regression function to it. And then we predicted a new value using the linear regression underscore 2 model. So this is how basically this is done. We could have also done it in another way, which was to create a new variable y underscore predict, and then did all of these things in a new line, and then simply replace this with y underscore predict. But both things are same, so it doesn't matter how you approach this problem. So as you can see, our model did pretty good. It almost predicted all the values correctly. So let's see how our polynomial regression results for a higher resolution looks like. So for here, as you can see, the polynomial regression, the curve is not pretty smooth. So because it gets one value of 1, then 2, 3, 4. So what about we add some values between 1 and 2, 2 and 3, and so on. So you you don't need to worry about this code. You can This is not a part of machine learning. It's basically you can write it on ChatGPT and it will show you how it's done. So this is a smoother curve, and as you can see, it predicts a lot of the values correctly, and most of them lie on the blue line. So now we want to predict a new result. So let's look at our problem statement again. And that new employee said that he was a region manager in his previous company. So his level was 6 and he had some experience also. So let's just say that his level would be 6.5 because he had some experience. So now we should check how much his salary should be. So first we will check that using our linear regression model. So it's easy. We have to just write len underscore dot predict, and then in a 2D array, we have to write the value of 6.5 over here because this model was trained on a 2D array. So anything you input should be a 2D array. So this shows that the value of the employee would be around 330,000, which is a lot than that he was of requesting. So, but now also check the result from a polynomial regression model, because as we know, the linear regression model in this data set did not work very efficiently. So again, what we are doing is we are putting 6.5 over here, applying the fifth transform method, and then predicting the new value using the len underscore 2 polynomial regression model. So let's see how this works. Okay, so it gives a value of around 160,000, and our employee was asking around 180,000. So we can tell the HR department that his salary should be around 160,000 according to the curve that we see over here. So this would help the HR department negotiate the prices and get a better deal out of it. So this is how we use polynomial regression. I'll also show you how things are done if we change the values of the degree over here. So let's just say we take a degree of 2. So what will happen here is we need to run all the cells again. Yeah, see what it does is it for level 2 it did 0, 2 to the power 0, that is 1, then 2 to the power, that is 2, and 2 to the power 2, that is 4. So similarly it changed the value of polynomials, or the values of the independent variables rather, as the degree shown here. So now we need to visualize the linear regression results again. And so linear regression result won't change because we made a change in the polynomial regression. So now let's check the polynomial regression results. Okay, so as you can see here, this model didn't work very well too, because it only predicted two values correctly. So we know that this model doesn't work. So now let's change this value to 3 again. Let's try with 3. Mm. So as you can see, degree 3 did somewhat better. As you can see, the distance from our model to these points reduced as compared to degree 2, but still I believe we could have done better. So we used 4 and we saw that the value was correct. So now let's also test for 5. So as you can see, the value of 5 works almost perfectly. It covers all the parts. For example, it goes through all the columns very nicely, and it almost predicts each value correctly. So now what we can do is we can predict the new value here and update the HR department on how much his new salary should be. So now let's check that. So the linear regression result won't change. So it's again 303,000. But let's see a new result on the polynomial regression and see how this works. Okay, so it gave a new value of around 175,000. And we know, as a matter of fact, that this is one of the best models that there could be because it is almost predicting everything correctly. So the person, that new employee, was asking around 180,000 as a salary, and our model shows that his salary should be around 175,000, which is a very good observation over here, which means that the person was telling truth and that his salary should be around that 180K mark. So this is it from polynomial regression, and I'll see you guys in the next video.